So welcome to part two. This is a question that I posted for you. Which muscle fiber type would have the fastest breakdown of ATP on the myosin head? So ATP is this molecule that gives you energy, and when it's broken down, it allows you to have energy for muscle contraction. The correct answer here is type 2B. It is the fastest contracting fiber. It has the highest amount of enzyme that breaks down the ATP at the myosin head. So the ATP, you can see, is associated here with the myosin head. When that's broken down, you get energy for muscle contraction, and that allows the myosin to form cross bridges with actin. So you need that energy for myosin to form the cross bridges and for muscle contraction to occur. The faster you can break down this ATP, the faster you can have contraction. So from this question, your fastest contracting fiber type is type 2B, next fastest is type 2A, and the slowest is type 1. And it all depends on how fast you can break down that ATP. So now with this slide, I wanted to give you just a different picture of myosin, and I wanted to kind of describe myosin in more detail. So you can see how myosin is arranged within the muscle fiber, and it's got a tail, and you can see that each myosin molecule actually has two heads and not just one. Sometimes I just draw it with one head to keep it simplified, but it actually has two heads. So this is a bigger picture of myosin. You can see the tail and the two heads. The two heads have a protein called heavy chains. So each head has one heavy chain, and it's the type of heavy chain that ultimately determines your fiber type and also the amount of ATPase activity you have. So that's the enzyme that breaks down your ATP to give you energy. So what happens in this reaction is you've got this molecule that's used for energy called ATP. It's broken down into ADP and inorganic phosphate. So ATP stands for adenosine triphosphate. It's got 3 phosphate groups. And then when it's broken down, you end up with 2 phosphate groups, adenosine diphosphate, and kind of a free phosphate. And the enzyme that helps this reaction to go faster is just called ATPase. So this is the reaction you get at myosin. You're getting breakdown of ATP to ADP and phosphate, and you get release of energy, and that drives muscle contraction. The faster this can go, the faster your contraction, and the speed of the contraction depends on the amount of ATPase activity. So if you're going to classify your fiber types and types of myosin heavy chains, so the type 1 fibers are the slowest contracting, type 2A are the next fastest. You've got this type 2X, which is your next fastest, and then type 2B is your fastest. These fiber types are all named based on the type of myosin heavy chain they have. So a type 1 fiber has only type 1 myosin heavy chains, type 2A only has type 2A myosin heavy chains, etc. Now, the slowest contracting has the lowest ATPase activity, so it breaks down the ATP the slowest, whereas on this end, you've got your type 2Bs, they have the highest ATPase activity, so they break down your ATP the fastest, and you have the fastest speed of contraction. The differences between the type 2X and type 2B are that type 2B are not found in humans. So these are found in a lot of animal species, and that probably explains why a lot of animals are faster than humans. Type 2X is your fastest fiber type in humans. So you've got type 1, type 2A, type 2X in humans, and then in animals you also have this type 2B, which is your fastest fiber type. Now, I mentioned that you have to break down ATP for muscle contraction to occur. You also need calcium to come in and bind with troponin to lift that inhibitory tropomyosin off of the actin to allow myosin to bind with actin. So you need two things to occur here for muscle contraction to be initiated. You need to break down that ATP to give the myosin energy, and you also have to lift that tropomyosin off of the actin to allow the myosin to bind to actin. So calcium has to come in, bind to troponin, and that allows you to lift the tropomyosin off of the actin. So you need calcium to be released in the muscle fiber, and you also need the ATP to be broken down for muscle contraction to occur. So the next question I have here is, where is calcium stored inside the muscle fiber? I've got a more detailed picture here that includes your myosin down here, your actin. I've got your tropomyosin, your troponin. You can see calcium coming in here to bind to the troponin. I'm going to put some labels on here. Calcium is stored inside this organelle called the sarcoplasmic reticulum within muscle fibers. And then you see this transverse tubule that comes down from the muscle fiber membrane and is associated with the sarcoplasmic reticulum. And what happens during contraction is that you have a stimulus that comes from your motor neurons, so your neurons that are located in your spinal cord. They're connected to your muscle fibers with axons, but they're not perfectly connected. So there's actually a space up here between the end of the axon and the muscle fiber membrane. But ultimately what happens is that neuron sends a signal to the muscle fiber membrane. You get this electrical discharge that comes down the transverse tubule, and that causes a change in the charge on the sarcoplasmic reticulum membrane, causing it to open and allow calcium to come out and bind with the troponin. So there's a number of steps here that happen with muscle contraction. And I've got this video. Again, I've posted a YouTube link to this within this PowerPoint presentation. So there's the link. And this video gives a nice presentation of everything that happens here. So I'm going to hit play here. So here you see this, it's called an action potential that comes down the muscle fiber membrane. Recall this comes from the motor neuron. And then it comes down the muscle fiber membrane, goes down the T-tubule. That action potential is then transmitted to the sarcoplasmic reticulum, which is represented here, here, and here in the diagram. When the sarcoplasmic reticulum is activated, you can see it releases calcium. The calcium comes down to your actin and myosin myofilaments and eventually causes contraction. So what you see here is they're blowing up the portion of the actin and myosin here to show you tropomyosin and troponin. So recall that tropomyosin lies on top of the actin and it blocks the binding sites for myosin on actin. So it inhibits muscle contraction. So the calcium is going to come in from the sarcoplasmic reticulum. It's going to bind to this troponin. And then once it binds to the troponin, you get a lifting of the tropomyosin off of the actin. And that allows the myosin to come in and bind to the actin and allows you to have muscle contraction. And I think it got stuck here for some reason. Try to play that again here. So you can see in this last part, you just get binding of the myosin crossbridge to the actin. So to summarize here, you've got the calcium that's released from the sarcoplasmic reticulum. It binds to the troponin. Troponin lifts the tropomyosin off of actin, and allows the myosin to bind with the actin. And again, there's the link to this, the video I just showed.